Alright guys, so today I'll be going through 1.4 to 1.6 review packet. So thank you for watching this video and welcome. Alright, so let's start with problem 1. So in this problem we are given that beta, this angle, is larger than alpha, is larger than gamma, right? We have these relationships between these angles. And we have to find all possible values of x, which is this side, given that x is an integer, right? This is just shorthand for x is an integer. So, what can we do for this problem? We can use the following logic. If beta is greater than alpha is greater than gamma, that means the side opposite to beta, right, is greater than the side opposite to alpha is greater than the side opposite to gamma, which means that 15 is greater than x is greater than 13. So therefore, the only possible integral value of x is x equals 14. Alright, 1b. In an isosceles triangle with side lengths 4, 9, and x, find the value of x. Okay, now there are two possible values of x. Either x equals 4 or x equals 9. But if x equals 4, what happens? We have a triangle 4, 4, 9, which is actually not a triangle. But when x equals 9, we have the triangle 4, 9, 9, which is a triangle. So the only solution that works is x equals 9, okay? Alright, so here are the answers. I'm gonna look at them. Question 2. Are there any congruent triangles here? Alright. So in the first one, we have that AB and CD are parallel. Right, they are parallel. So because they are parallel, it might feel like these two triangles are already congruent. But they are not. Because the only thing we know is that angle F, angle AFB, is equal to angle DFC. Angle FAB is equal to angle FCD, and angle FBA equal to angle FDC. We only know these three things. And then three angles is not enough to prove congruence. However, later you will learn that there's actually a special term for this that is called similarity. But the conditions are insufficient to prove that it is congruent. So our answer would be insufficient. Okay. Next one. Given that AD is equal to DC and angle A is equal to angle C. At first glance, this feels like it is impossible for it to be congruent. However, if angle A is equal to angle C, what else do we know? We know that BC is equal to AB, because ABC is an isosceles triangle. Now we can prove congruence. Right now we can prove congruence. So, triangle A DB is congruent to triangle CDB, right? Remember that the order in which you write it matters, because DB is to DB, AD is to CD, and AB is to CB, right? The order in which you write it matters. And this is by SAS. If you want to write it out, this is because angle A equals angle C, AD equals CD, and BC equals AB, or equals BI. Yeah, so this one is congruent by SAS. Last one, given that angle A equals angle D. This one is actually insufficient, because we are not given at any point that these two are parallel or these two are parallel. We are not given that. So we cannot assume right, let me write it in all caps, cannot assume AB is parallel to CD or AC is parallel to BD. So if we only know that AD is parallel to, if we only know that angle A, BAD is the same as BDA, right? If we only know that, it is not enough to prove any congruences. So insufficient. Yep, okay. Problem 3. Line N is parallel to AB. This is line N, right? This is line N. This is AB. So first of all, find X. Okay, so how would you find X? Well, we would have to use properties of parallel lines. Because this angle is equal to this angle. So we can say that 2x plus 16 is equal to 8x minus 8. Instead of getting everything out, a quicker way, well, a marginally quicker way would be to factor this first. And then divide by 4. And then you get this, sorry, minus 32, so 5x is, not 5x, negative 3x, 40x equals 40 over 3. Okay, I thought I chose an integer here, but turns out I did not choose an integer, so I am sorry about that. 3b, find y. How would you find y? To find y, you would have to add this, this, and this together. Because you know that the sum is 180. Okay, so find y. First of all, we have 8x minus 8. Why did I choose these numbers? Those were terrible numbers to choose. Okay, 8 times 16 over 3, which is what? Which is... what is this? 8 times 16 is 32, 68, 128 over 3. And then what about this? 5 over 2x minus 10. At least this number is a little better. 100 over 3 minus 10. 70 over 3. And then y would just be equal to, so we know this plus 70 over 3 plus y equals to 180, or yeah, and then this would just be 198 over 3. It is 198, right? And then 180 would be what? 540 over 3. So y would just be equal to 342 over 3. I genuinely thought I picked better numbers than this, but y is equal to that. Okay, next problem. Which side is larger, AC or BC? Justify your reasoning. How would you do this problem? So in here, all you are given are a few angles, right? You are not given any side lengths, but you are given that ACB, angle ACB, this angle is equal to how much? Is equal to 128. No, 100. Wait. Yeah, this angle is equal to. That's a good question. Oh, you know that this angle is equal to 70 over 3. And then you also know that the other angle is equal to 128 over 3. And then finally, you would know that this angle is equal to y, which is 342 over 3. Right. Given my calculations are correct. 40 over 3. Yeah, okay. Yeah. My calculations should be correct. So how do we compare this length of AC and BC? We can use the proposition, I think it's 1.18, which is that a larger angle must subtend a larger side. So in other words, AC is greater than BC if and only if, right, here's just some fancy mathematical notation, right, to say that it's kind of biconditional, right? So AC is larger than BC if and only if angle B, because B is opposite AC, is greater than angle A, because A is opposite BC. In other words, what this is saying is if this is true, then this is true. And the converse is also true. If this is true, B is larger than A, then AC is also larger than BC. In math, we call this is a biconditional statement. Right, okay. This is just some fancy math notation. And then is angle B larger than angle A? No. But this is not true. So this is not true. So we have BC is greater than AC. Right. And then you can write the justification on your side, on the side, use like your propositions, etc. All right. Number 4. Consider the following diagram where these two are parallel. First of all, find x. How we find x here? This is really just a quadratic. We would have to add all 3 angles together and get that this is equal to 180 degrees. So x squared plus 6, x squared plus 50, x squared plus 2x plus 4 equals to 180. 3x squared plus 2x plus 60 equals 180. 3x squared plus 2x minus 120 equals 0. And then from here we can just factor 3x and x. What is it? 6 and 20. Yeah. 6 and 20. So x is either 6 or x is negative 20 over 3. However, you would have to check for extraneous solutions. Right. So if x were negative 20 over 3, would that work? So if x is negative 20 over 3, this angle would be positive. This angle would be positive. This angle, would it be positive? Negative 20 over 3 squared is positive. That's like what? That's like 36, approximately 36. This is approximately like negative 13, and this is positive 4. So this angle would also be positive, right? So in this case, x equals negative 20 over 3 is not extraneous. So both solutions are not extraneous. Right, and I was looking at all of your previous tests and I was grading them the other day, and many of you struggle with the idea of extraneous solutions. So the idea of extraneous solution is that this solution is a solution for x. However, it does not fit into the scenario that we want to consider. For example, if the answer was asking for a time or a speed, your speed could not be negative. So your solution for x does not fit the scenario that you want it to fit into, right? That is the idea of extraneous. Even if it's just negative does not mean that it is extraneous. For instance, in this case, negative 20 over 3 is not extraneous because it does meet the requirements that all the angles are positive. You would have to plug the number back in to the scenario to make sure that the scenario actually works. Hint, hint. You might see a question like that on your unit test. Okay? 4b. Find angle DBC. Okay. If we're given that AD is parallel to BC, DBC, which is this angle, is equal to this angle. So we just have to find ADB. And angle ADB is easy. It's x squared plus 6, which, yeah, I should have, okay. Yeah, so theoretically there are two answers for x, but I will really kind of just focus on this one because this one's the easier one to work with, okay? Which is equal to 6 squared plus 6, which is how much? Which is 3642. And the last one. So we are given that angle BDC is 6, 7. Okay, yeah, I chose that on purpose. Yeah, if you like math, you put some funny numbers in there and it all gets good. So if we're given this is 6, 7, we want to find DCB. We know that this is 42, this is 6, 7, and then angle DCB is just equal to 180 minus 42 minus 6, 7, which is equal to 80 minus 109, 61, I think. Is that correct? Oh no, 71, my bad. 71 degrees. All right. Okay. I feel like these questions aren't that fun, but once you get to like question 5, it's getting a lot more fun. Number 5, prove that diagonals of a parallelogram bisect each other. So let's draw the diagonals. We want to prove that they bisect each other. In other words, if this is point P, we want to prove DP equals BP and AP equals CP. I want to prove that. What are we given? These two are parallel. These two are parallel. And this side is equal to that side. Okay, so now how do we go on proving that these diagonals bisect each other? Really, right now we only have one tool in our toolbox, and that is triangle congruence. So if we can prove that triangle ADP is congruent to triangle BCP, is it BCP? Yeah, sorry, CBP, because you have to write them in order. If we can prove this, then we can prove desired. Okay. Or then we know that DP equals BP and AP equals CP. So all we have to do is prove that by CPCTC. Right? Because you have to write that. Okay. Alright. So how would we prove this? We already had that AD is equal to BC as given. right? What else do we have? Because these are parallel, this angle is equal to that angle. Angle ADP is equal to angle CBP. And we have angle, the other angle is also equal. So this angle is equal to that angle. DAP is equal to angle BCP. And this is enough, and this is actually already enough to prove our triangle congruence, because this is just ASA. Right? So as a result, ADP is congruent to CBP, and as a result, proof as desired. After every geometry proof or after any proof, you always draw this small rectangle. Okay, this problem. Find x and defining extraneous solutions. So in this, we have 17 over 19x plus 10 equals 180, 170, and then here you do not multiply the 19 immediately. You first try to cancel, not actually canceling. So this becomes 1 and this becomes 10, and then you have x is equal to 190. All right. Okay, this problem. X squared plus 24x equals 180. X minus 180 equals 0, and then you factor. X minus, well, what is 180? 6 and 30. Not 6 and 7. Okay. 0, so x is equal to 6, or x is equal to negative 30. And negative 30 is extraneous because 11x, 11 times negative 30, is less than 0. Right. It is not extraneous because x is negative. It is extraneous because one of the angles are negative. Right, let me repeat that. This hint might be on your unit test. X is extraneous, x equals negative 30 is extraneous, not because x is negative, but because 11x, one of the angles in the triangle, is negative. So this is why this is extraneous. And 6 works because all the angles are positive. This problem. We have 5x squared minus 10x plus 15 is equal to 90 because this is a right angle, right? So if all three adds up to 180, these two add up to 90. And then factoring. Simplify, just divide by 5. And then this is familiar. So you have these two answers. In these two answers, which one is the extraneous one? Let's think about it. Here, actually, x equals 5 is the extraneous one. Because if you plug 5 back in here, this is less than 0. This is like what, negative 15, negative 35 actually, right? This is less than 0. So 5 here is extraneous. But on the other hand, negative 3 is actually not extraneous because this is positive and this is positive. Okay, so in here, negative 5 would be the extraneous solution and negative 3 would be the actual solution, would be the non-extraneous. Okay, and the last one is something one of my favorite problems in a book called Challenging Problems in Geometry. Yeah, if you're a math enthusiast, you should buy it. It's a great book. I love it. And it's not directly copied from challenging problems in geometry. It uses the same idea, but I modified the problem a bit. If you're curious about what the original problem was, the original problem was very similar, but I'll cover that after I explain this problem. Okay. So in triangle ABC, AB is extended to P beyond A. Right, AB is extended to P beyond A. And D is parallel to AB, and Q is extension of DE past E. So QD are collinear. Given that BE is the angle bisector of ABC, and AQ is the angle bisector of PAC, find the length of QD if A equals 4 and DB equals 6. Okay. So for geometry problems, the first step is to read the problem and mark what you know. So we know these two angles are the same, right? Because B is the angle bisector, and these two angles are the same. Same thing, angle bisector. I want to find the length of QD if A equals 4 and DB equals 6. Okay, how would we solve this problem? That's a good question. Let me give you a hint first, right? We haven't used the condition that DE is parallel to AB. We haven't used this condition yet. That's hint 1. So you can pause the video and try to figure it out yourself if you want to. Okay. So if you still cannot figure it out, here is another hint. What is EBA also equal to? What is another angle that EBA is equal to, given that it's parallel? What is QAP equal to? Right, here's another hint. So pause the video again, try to figure it out yourself. Okay, solution. As D is parallel to AB, we have that angle QAP is equal to angle AQE, because they are alternate interior angles. However, this implies that EAQ is isosceles. So, QE is equal to 4. Similarly, we also have that angle ABE is equal to angle DEB. So, this implies that angle EDB is isosceles. What does this mean? DE equals 6. So DQ is equal to DE plus QE equals to 4 plus 6 equals 10. Right, so this is a really cool problem, and the biggest takeaway I want you to get for this problem is that angle bisectors, if you're doing competition math, I think this is pretty important. That angle bisectors usually are pretty unuseful by themselves. They can be a lot more useful if you turn them into isosceles triangles. If you turn them into isosceles triangle, because then you can use that information to find unknown side lengths. Yeah, okay, and this is all for today. Hope you're doing a lot of math in the October holiday, and I will see you next time. Thank you.